Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP ENARSI version 8 course curriculum, and in this packet tracer tutorial and activity, we're going to be taking a look at the old school configuration for a site-to-site VPN, IPsec VPN, using the CLI, and we're going to be applying a crypto map. So again, as I said, crypto maps are sort of a thing of the past, not that they aren't useful or don't have a use case today. However, there are newer ways to accomplish things, and I'll talk about that as we go through the video. We're going to be focusing mostly on GRE over IPsec as well as SVTIs, or static virtual tunnel interfaces, when we're talking about site-to-site connectivity that we might be configuring. So let's go ahead and dive in here to the activity and take a look at what we have. So here is our topology. We've got 3 routers, 3 sites, if you want to look at it like that. And here's where we're going to be configuring our IPsec VPN tunnel. Now you'll notice I'm not saying anything about GRE because GRE is not involved. You can have a pure site-to-site IPsec VPN with no GRE. That is not a requirement to have a site-to-site tunnel. So we're going to be doing it with IPsec. Here is our addressing table at the top. Again, the background scenario, and this is one of those nice activities for learners that it's actually going to kind of prompt you and walk you through things so that you can see how things work. So here's a list of the parameters that we're going to be using for Isocamp Phase 1, and they refer to it as IPsec Phase 2. Now, again, this is sort of like splitting hairs in a way. You could say Isocamp Phase 1, Isocamp Phase 2. You could say IPsec Phase 1, IPsec Phase 2. But again, I typically just say Isocamp Phase 1, Phase 2, or Phase 1, Phase 2, because it's kind of understood that this is how you're going to be configuring it. And the reason that they say Isocamp Phase 1 is because it's typically in Phase 1 where you're configuring the Isocamp settings and the Isocamp key. And they call it IPsec Phase 2 because that's where you're setting the transform set and the encryption parameters. So again, typically I just say, Phase 1, Phase 2, or Isocamp Phase 1, Isocamp Phase 2, which is different from IKE version 1 and IKE version 2, right? So keep that in mind as we work our way through here, because we're going to be doing this is all IKE v1 configuration. And so we've got some passwords that have been configured, and that is always a concern when you're typing things in. So let's jump onto PCA, and let's go ahead and do what they want us to do here, which is ping over to PCC. So can I ping over to 192.168.3.3? And again, PCA has no idea how to get to that network. It doesn't have a route to that network, so it's going to send that traffic to router 1, its default gateway. How do we know it's the default gateway? Well, you can see it's configured right here on the PC. Router 1 is going to get that traffic, and let's see if router 1 has a route to get its traffic over there, and here's where we're going to have to scroll back just a skosh. So Cisco Con PA55, and then we're going to get into privilege exec mode here, Cisco ENPA55, and let's say show IP route. And you can see that we have an OSPF learned route to get us over to the 192.168.3.0 network. So we are able to ping, and the ping is successful. So now what it needs us to do is on router 1, we need to enable the technology package that's going to allow us to configure IPsec. And again, this is true on the 1900, the 2900, the 3900. It's all sort of the same. And so what we're going to say is license boot module C1900 technology package security K9. And you'll notice you can disable it, but that's not what we want to do. Now we get the EULA, right, the right to use, and we're going to say, yes, we accept that. Now, here's the mistake most learners make, is that they don't reload the router. So from here, I always like to save my configuration and then reload the router in order to enable the license. And it's something that you have to do in this activity, excuse me, and on real Cisco routers in order to get access to the IPsec configuration parameters and settings. Oops, sorry. So we'll say Cisco Con PA55, and we'll get back into privilege exec with Cisco ENPA55. All right, so here we are. And if I was to say show license, we would see, oh, sorry, that's going to want us to say show license. Is it technology or all? So license all. And so here you can see a list of all the licenses in the IP-based K9. And there is our security K9, right? So we've got the security package installed. Now, again, remember, we're going to be doing this applying a crypto map, right? And so a crypto map is going to imply that we're going to have an ACL. And what this ACL is doing is it is going to match the traffic for which we wish to encrypt, or for the traffic that we wish to encrypt, right? And that's really what the access list is doing. So let's get back into global config and let's go ahead and set that up. So we're going to say access list 110. Permit, in other words, match the traffic from the 192.168.1.0.000.255 wildcard mask. Did I get that right? Yep. And going where? So that's the source. Where's it coming from? So it's coming from that network segment, which again is the network segment here behind router 1. So any traffic that has an IP source address in that range and an IP destination address, and again, we're assuming it's IPv4 here, and an IP destination address in the 192.168.3.0.0.0.255. Any source IP in the 192.168.1/24.0.1/24, or all right, so say let me correct that. Let's start again here. So any IP packet with a source IP in this network range, 192.168.1.0 to 255. Going to this destination IPv4 address, which would be in the IPv4 packet header, 192.168.3.0/24, any IP packet that matches those parameters is going to be encrypted between those two sites, right? So it's going to be matched for encryption. So sorry about that. Got a little tongue-tied. So now we do the fun part, right? And this is all about the IKE phase 1 or the Isocamp phase 1, right? Which is different. IKE V1 and V2 is totally different. So Isocamp phase 1. And so we're going to say crypto Isocamp. And it's nice here. They kind of walk you through it. So policy 10. Now there's certain things that we're going to configure here. And I'm going to touch on a few things. So encryption AES, we're going to be able to do 256. And this is for protecting the keying material. That is what phase 1 is all about. Because again, we've got to pass our keys. This is public key cryptography. We've got to pass the keys somehow, but we have to make sure that those keys are protected. And this is one way that we do that. So we're going to say authentication pre-share. So what kind of a key are we going to have? Is it going to be a certificate key, or is it going to be a pre-shared key? So we're going to be doing a pre-shared key. Now, here's the Diffie-Hellman group number. Now, these groups right here are great for demonstration purposes, with the exception that these groups should no longer be used. In fact, I think it's almost 10 years ago that these groups were considered unsecure and no longer viable. So we should be using group numbers that are much higher. Group 19, I think it's 21, 24, where we're talking about elliptical key cryptography. But again, groups 1, 2, and 5 for demonstration purposes are going to work just fine. Just keep in mind that these are not the groups that you would be using or that you would want to use, because these are not secure. So we're going to say group 5. And then we're going to exit out. Now, there's some other things we could set here. I guess we should talk about that. The lifetime, how long do we want the keys to last before we rekey? Do we want to set a hashing algorithm, right? And the answer is no, we're not going to be setting those things here. And so let's exit out. And here's where we're going to go ahead and configure that pre-shared key. So crypto Isocamp key, VPN, PA 55. Now, the address to which we are going to be setting this up. Sometimes you'll see the quad zeros in here. Not a good idea. We want to put the specific address of the site to which we are going to be creating this IPsec VPN tunnel. Again, there is no GRE involved in this tunnel at all. All right, so that takes care of our Isocamp phase 1, the keying material. How are we protecting the private keys and the public keys? How are we protecting the public keying information that's going to be exchanged? All right, now we're going to go down to Isocamp phase 2, and here's where we do our transform set. And we call it the transform set because we are encrypting the information. So crypto IPsec transform set, we're going to call this VPN-set. And again, that name, because of packet tracer, we need to have that name, but you could use another name if you would like. Now, in the transform set, and this is a very consolidated list of options that you're probably going to see on a real Cisco router. However, here, we're going to be setting ESP AES, and then ESP SHA and HMAC. Now, we'll get into a conversation about ESP as well as other approaches that we could use, AH, which is Authentication Header. And I mean, those are the two. It's going to be ESP or AH. Now, you typically don't use AH because ESP includes the capability of authenticating the header, right, and doing the hashing, which is what we're doing with that ESP SHA HMAC command there at the end, where AH cannot encrypt the information. If you're using authentication header, you can't encrypt the information, right? There's no C in that CIA, the confidentiality, integrity, and authentication. There is no C when you're using authentication header or AH, which is why you typically see ESP used here. All right, so that's what we're going to stick with. So we've got AES for our encryption method. We've got SHA HMAC for the hashing portion of things, and that does it for that. And we're going to leave it right there because now we configure the crypto map. And here's where the ACL comes back into play. So we say crypto map, VPN-map. Again, this name, VPN-map, you can make it anything you want. However, here, for packet tracer purposes, we're going to leave it as VPN-map and IPsec Isocamp. So this is an IPsec Isocamp crypto map. We'll hit enter. Oh, okay, yeah. So when we have a valid peer ACL configured, we'll be set and ready to go. So here's what we're going to do now. We're going to set our description, right? Always a good idea. So VPN connection to R3. And now we're going to set the peer for the map, right? 10.2.2.2. We're going to set the transform set that we're going to use, which was VPN-set, which we configured earlier. And then we're going to match the address, right? And what we're really saying with address is match the ACL with the number 110. Then we're going to type exit. So now we're going to go into interface serial 000, and we're going to apply that crypto map. So crypto map VPN-map. Now, as I've said at the beginning of the video, this is an old school way of doing things. Now, is there some corner case where maybe, hey, a crypto map is how we should do it? I'm sure that there is. However, there are much better ways to do this that give you a little bit more flexibility. However, this is a pure IPsec VPN site-to-site tunnel, and we have it set up here on router 1. So now let's go ahead and go down and save our configuration with a quick write mem. And let's take a look at what they've got us doing here. So now they're going to walk you through how to do router number 3. So let's jump on to router 3, and as you can see, we're going to have to do Cisco Con PA55 and then Cisco EN PA55. And let's go ahead and get into global config, because here again we have an access list that's got to be configured on this side to ensure that the traffic can be encrypted going the opposite direction. So in other words, we're going to be matching with permit IP, and again, IP and an ACL matches everything, right? Remember the other options, some of them are TCP or UDP or ICMP. However, we're not using very specific matching criteria here. We're saying match all IP traffic. So access list 110, permit IP, and this is, we're going to match traffic from the 192.168.3.0 network going to the 192.168.1.0 network, and that is the traffic that's going to be encrypted. And that's why we have these ACLs on both sides. Okay, so from here, where did I leave off there? Yeah, so we're on step number 3 here. Sorry about that. All right, so now we're going to go ahead and configure. And again, you can see here, right? So I think this is kind of funny, right? Because here, how do they refer to it in step 3? Configure the IKE phase 1 Isocamp, right? So IKE phase 1. Remember, I said you could say IKE phase 1, IKE phase 2. You could say Isocamp phase 1, Isocamp phase 2. But typically, you don't say IPsec phase 1 because you're not really doing much IPsec in phase 1. You're typically doing it in phase 2. But again, you can see how it can get a little complicated here. So again, typically just ISAKMP phase 1, ISAKMP phase 2, IKE phase 1, IKE phase 2, and you're good to go. Remember, IKE phase 1 and IKE phase 2 are totally mutually exclusive from IKE version or IKE v1 and IKE v2. Totally different, right? Totally different. So let's go ahead and walk through this again. But I think what we're going to find here is if I was to say crypto ISAKMP policy 10, oh, and it looks like they already installed the license for security K9. So we're going to go ahead and go with it here. So let's go ahead and do the encryption AES 256. We're going to do the authentication pre-shared. This is our pre-shared key. We're going to use our Diffie-Hellman group 5 in order to protect the keying material. We're not putting a hash on here. We're not putting a lifetime on this before it needs to be rekeyed, and we are exiting. Then we're going to come back and say crypto ISAKMP key VPN PA55 and the address of 10.1.2. Oops, sorry. Got to be careful here. 10.1.1.2. Again, this is the serial 000 interface of router 1. And what would be, we're using RFC 1918s here, and I understand why. However, in a public internet scenario, if this was something you were trying to do, you would use the publicly routable IP. Like, which IP can I use to reach the peer node? All right, so now we're going to say crypto IPsec transform set VPN-set. And again, this is going to be ESP AES for our encryption, and then ESP SHA and HMAC for our hashing, because ESP, the Encapsulating Security Protocol, can do it all. Authentication Header cannot do encryption, right? So if you're just using AH, you're not encrypting your traffic, right? You're not encrypting your traffic. So let's say crypto map, and we'll say VPN-map 10 IPsec ISAKMP, because that's the type of crypto map this is going to be. It's an IPsec ISAKMP map. We'll throw a quick description in here. VPN connection to router 1, and we'll set our peer to 10.1.1.2. We're going to set the transform set that we configured, right? And the transform sets, and this is important, need to match, right? At least there need to be matching criteria in the transform set. Again, I could put on a real Cisco router, there are many more options here that you could put. In fact, if I was to pull up a real Cisco router, let's see if we can get that. Let's go conf T, and then I'm not sure if that is actually on here. Yeah, so I don't have it on this router. I would have to boot up, or wait, I'm sorry. Crypto IPsec transform set. It is on here. All right, and I'll just call it, blah, blah, blah. And you can see you have many more options. And in fact, on newer Cisco routers, this is running 15.1 code. This is a 2811. So this is definitely an older router. But on newer routers running the 15.8, 15.9, you are going to have many, many more options from which to choose. And again, the options, you need to have at least one set of options that are matching in order for this to work. And typically you may see some net engineers who will add in multiple options here just to make sure that, we're going to get a connection. However, my, apprehension in doing things like that is, if you're setting both sides up, you should know what the transform set encryption and hashing algorithms are. So it shouldn't be a guessing game. So again, you should only have, my opinion is that you should really only have what you need in here when you're configuring both sides. This should not be, I'm going to put a whole bunch of things in here in the hopes that this is going to work, right? You should know. So we're going to set the transform set to VPN-set, and then we're going to match that access control list, right? So match address 110. And that is it. We go into the interface, and let's double check here. Do show IP interface brief. So what is the 10.1.2 or 10.2.2.2? And in fact, it is a different interface, serial 001. And we're going to say crypto map and VPN-map. And that is going to turn the crypto map on. Now we're into the verification phase here. So let's go ahead and let's get out of here. Let's get out of here. Let's save our config with a right mem. And let's say show crypto IPsec SA, right, for the security association. And what do we see here? So here's the crypto map, right? You can see right there, that's the map tag. Here's the local address, 10.2.2.2. You can see that we have the local identity information right? So that's the local network traffic that's going to be encrypted going to this remote network, right? The remote identity. And there is our peer, 10112, and we're using port 500 for IPsec. Now you'll notice that there's no packets encrypted or decrypted anywhere here, and that's okay because there hasn't been any traffic sent back and forth. So it would make sense that nothing would be encapsulated, in other words, encrypted, nothing would be decapsulated, in other words, decrypted. And let's now go ahead and generate some traffic. We're going to ping from PCC over to PCA, and let's see if this works. So we're going to say, 192.168.1.3. So again, in the IPv4 header that arrives at router 3 from PCC for this ping traffic, this ICMP traffic we're sending, the destination network will be the 192.168.1, and the source network is going to be the 192.168.3. That should match that ACL 110 that we created, and that traffic should be encrypted. The return traffic, the ICMP echo replies, should also meet the criteria on router 1 for encryption, and that traffic should make it back. So there we go. We had some timeouts, but that's okay. That's typical. And then we've got our traffic working without a hitch. And so now if we were to go back onto router 3 and rerun this command, you can see that we've got packets being encrypted and packets being decrypted, right? So everything worked as planned. Now, on router 1, we're going to reissue, we're on router 3, but it's the same. You're going to see the same thing over here on router 1 when we say show crypto IPsec SA. And there's the information. Again, it's flipped, right? Because we were pinging from the opposite side. So now, and it's interesting here, and no pun intended with that statement, but I'm glad that they had this here, create uninteresting traffic. So one of the things that you'll hear people say is we want to match the interesting traffic, right? The traffic that the router is going to be interested in encrypting. Well, now what we're going to do is we're going to go to PCB, and we're going to create uninteresting traffic. In other words, traffic that is not going to meet the access control list criteria for encryption. And the way we could do that is, remember, the IPsec VPN tunnel, this doesn't physically exist right here. This logically exists using these serial connections, right? And we could think of this as like, this would be the internet out here possibly, and the traffic is transiting the internet, and we want it to be encrypted. This is a way to do that. Now, I should also point out on router 1, if I say show IP route as we did before, how are we learning about that remote routing information? Yeah, we're learning about it via OSPF. In an internet scenario, right, it wouldn't be OSPF that we would use to learn that information, because these would be publicly routable IPs we would be using as our source and our destination. It would be probably BGP, right? Or maybe we're using static routing of some kind. But the bottom line is that this is not a physical connection. This is a logical IPsec VPN tunnel, right? It's an overlay. And we are tunneling through this network, and our traffic is encrypted. So now we're going to be creating uninteresting traffic by simply pinging over to PCA at 192.168.1.1. And, not 1.3. Let me change that. That's the inside interface of the router there. I apologize. But again, it's going to work. And the reason that this works and we don't have any problems is because it's uninteresting traffic. It's not going to get encrypted. And again, on router 2, as you saw, there is no encrypted traffic. We didn't set any IPsec VPN tunnels up here on router 2, right? This is just a transit point for all that traffic. All right, so router 1 to PCC is not interesting traffic. So verify the tunnel, show crypto IPsec SA. I think we've done that enough. And then check results. And so we are at 100%. Again, this is a nice activity to kind of walk you through how to set up an old school IPsec non-GRE VPN tunnel leveraging crypto maps. And again, this was one of the early ways that Cisco came up with doing site-to-site IPsec VPN without GRE. And this is really not how it's done anymore. In the description of the video, I've got multiple links down there for multiple videos where I go into great detail about GRE over IPsec and how to configure SVTIs using IKE v1 and IKE v2. So two totally different ways that you can set it up. Again, IKE v1 is legacy. IKE v2 is really what's being used on sort of greenfield deployments today. Right? As long as, again, greenfield being the key word there, if you're trying to integrate with IKE v1 and IKE v2 are not backward compatible. So it's going to be all IKE v1 or all IKE v2. Again, different from the phases. All right, well, that is going to wrap up this video tutorial on verifying and configuring site-to-site IPsec VPNs with the CLI on Cisco routers. Thank you guys so much for watching. As always, let me know if you have any questions, and as always, I hope to see you in the next video.